Good morning, my YouTube viewers. Crystal here. I just wanted to make a YouTube video for you for what I've been working on for last night, yesterday, and last night. Basically, what I had done is I had been working on this traffic forecasting video, and I decided to use ADA Boost Regressor, but I've used that in the past, and I thought, well, I don't want to keep using the same algorithm because that defeats the purpose of learning data science and learning machine learning if you're using the same algorithms over and over again. So I decided to use another algorithm. What I'm going to do is I'm going to leave the link to my GitHub account in the description box down below so you can go onto the program and you can follow along with me. So basically, I used another algorithm. I used the bagging algorithm to solve this problem. And what we'll do now is we'll talk about the problem statement for this problem. It was a traffic problem with Analytics VidHire, but it had originally been called McKinsey Analytics, I believe. So this is the problem statement. You are working with the government to transform your city into a smart city. The vision is to convert it into a digital and intelligent city to improve the efficiency of services for the citizens. One of the problems faced by the government is traffic. You are a data scientist working to manage the traffic of the city better and to provide input on infrastructure planning for the future. The government wants to implement a robust traffic system for the city by being prepared for traffic peaks. They want to understand the traffic patterns of the 4 junctions of the cities, traffic patterns on holidays, as well as on various other occasions during the year, differ from normal working days. This is important to take into account for your forecasting. To predict traffic patterns in each of these 4 junctions for the next 4 months. The sensors on each of these junctions were collecting data at different times, hence you will see traffic data from different time periods. To add to the complexity, some of the junctions have provided limited or sparse data requiring thoughtfulness when creating future projections. Depending upon the historical data of 20 months, the government is looking to you to deliver accurate traffic projections for the coming 4 months. Your algorithm will become the foundation of a larger transformation to make your city smart and intelligent. So that's your problem statement. So the first thing we're going to do is we're going to import the libraries that we're going to need to use to complete this problem. And then we're going to import the CSV files. These files can be found on the Analytics VidHire website, but you're more than welcome to download them from my GitHub account if you want to. So we look at the train file. You see the train file has a date, time, a junction, a vehicles, and an ID number. The test file has the same thing as the train file except for vehicles. And this is your sample. Your sample is going to be your ID and your vehicles. So we do info on the train file, and you find out that the date time is an object and everything else is an integer. The same thing with the test file. We check to see if there are any null values, and no, there are not any null values, so we don't have anything to impute. The next thing we're going to do is we're going to take a train ID equals train ID, and ID train equals train ID, and ID test equals test ID. And the reason why is we're going to drop the ID number from the data frame because it isn't needed. So the next thing we have to do is we have to rename the columns, and you don't necessarily have to rename the columns, but because I was working on this problem with Prophet wants the columns to have a certain name, so we just went ahead and renamed the columns as DS, add 1, and Y. And now what we're going to do is we're going to graph the data, and you can see a graphical representation of the data. And now what we're going to do is we're going to convert DS to year, month, day, and time. So since it's an object file, it's a string. So we've just taken out bits of the string to extract the year, month, day, and time. And now what we have to do is these columns that we have created are objects, and the model will not accept objects. So we have to convert these columns to integers. And then so we've got our train file. So you can see you've got a DS, add one, a Y, a year, month, day, and time. Now what we have to do is we have to define our X and Y variables. Y is train Y values. X is train drop Y in DS axis equals 1, and X test equals test drop DS axis equals 1. Now we split the training setup for testing and validation using train test split. So X train, X Y val, Y train, Y val equals train test split, X Y test equals 0.1, random state equals 1, and then we check the shape of all of these data frames that we're going to be using. And now what I did was I did a make pipeline. So model equals make pipeline, standard scalar, bagging regressor, which had a base estimator as a gradient boosting regressor, and we fit it on X train, Y train. So we print the model out. We print the score out. The score was 91.30. And now what we do is we predict on the validation set. YPRED equals model predict xval. YPRED equals YPRED as type int. Print model score xval yval, and then print another score. So we had 90.09% accuracy on the xval and 99.9% on your R2. Now we check our YPRED, which is an array. And then what I did was I made a data frame to predict the actual values against the predicted values, so you can compare that. And then I plotted it as a graph so you can see a visual representation of the actual values against the predicted values. And now what we do is we predict on the test set, and that's final labels. And then when we get our final labels, which is an array, we prepare a data frame, which is going to be called submission or output. And the data frame is the ID is going to be ID test, and the vehicles is going to be final labels. So output to CSV is submission.csv index equals false. It says print, your submission was successfully saved. So we saved it, we upload the submission, and so you got your submission. And then so what you do is you take your submission file and you put it into the Analytics VidHaya website and under the solution checker. And when I put it under the solution checker, I got a 12.74% private score. And so I know you can't see it because my screen recorder only allows me to score, like check on one tab of Chrome, but it's like 3 times better than Prophet. Well, definitely 3 times better than Prophet, and almost 4 times better than stat models. So, which is unusual because, stat models are supposed to be so great. Stat models are supposed to be the model that you're going to use when you're doing time series analysis. But from what I've seen experimenting with stat models, it's not really that good. And so this is just another way you can do time series forecasting. So I thought I would show that to you. If you like my video, please like, subscribe, and share. If you like the work I do and want to support it, I'm going to leave my email address in the comment section in the description box down below, because I don't have enough subscribers to monetize, so I have to ask for donations. Thank you so much for watching my video, and I look forward to making new videos for you.